All right, I'm going to go ahead and get started. Welcome. My name is Ryan Lowe, and I am building an Amazon Alexa skill. So I work for the Amazon Alexa team. I am a technical evangelist. My job is to educate and inspire developers to build with Alexa, particularly Alexa skills, the kind of skills that run on Echo devices back here. So custom skills that any developer can build and give Alexa more functionality. And part of that is that I have to then also be building skills and staying up to date on everything. And so while I'm doing that, which is part of my job, I am live streaming it. So I've been doing this for about the last 6 weeks, and I'm going to continue to do this until I'm done. The live skill that I'm working on is actually one that will hopefully be used. My intent is to publish this into the store and allow anyone to use it, but I'm also open sourcing it so that anyone can download it and run the infrastructure. So what is it? It is its ability to pull down YouTube videos and transcribe and index them to be able to make them searchable on an Echo device. Specifically, what I'm working on is for pulling down Amazon Alexa developer office hours videos and making them searchable. So every Tuesday, myself and a co-host, Jeff Blankenberg, and sometimes we have other guests, get online. We stream to a variety of different platforms in real time, and we allow developers to come on, ask questions, and we answer them. And then when we're done, that video of hour-long content gets archived in YouTube, and now we have hours and hours of YouTube videos saved there. The issue is that if you're a developer and you have a question, and it's not Tuesday morning, so you can't join us online, you can join our Slack community, but more importantly, we have all these hours of videos where we're answering questions. Probably we've answered your question, but how do you get that? How do you get the answer when there's just hours and hours of video? And you know, I'm not expecting people to sit down and just watch hours and hours of video hoping that someone asks their question so that they can get the answer. So what I'm doing is I'm building a system, an architecture that will, as soon as that video lands in YouTube, we pull it down into AWS. That's where this entire architecture is. And we process it, we index it, and then we make it searchable. And then the end result is that on an Echo device, I will be able to say, show me from office hours where Ryan and Jeff were talking about dynamic entities or Alexa presentation language or APL Ninja or a variety of different topics that we talk about. And it should go right to that point. It should find the right video, the right episode. It should zoom to that point in time in the video and start playing at that point. So that's what I'm hoping to get to. I did build a proof of concept of this last year, and it did work. So I'm very high confidence in this going forward. But now I need to actually build out the entire architecture and make this like a nice, stable system that is automated and will automatically go through all this. So I do have a GitHub repository where I am persisting all this. I am building this all inside of AWS. That's where the entire infrastructure lives. I'm doing my best to make this as serverless as possible, although I did just create an Amazon OpenSearch database cluster, so there is a stateful database in here now that's running 24/7. I am going to challenge myself to figure out a better way to do full text searching without OpenSearch, even though that is the database that does this. But for right now, I'm just going to go forward with it. This is a terrible architecture diagram. I'm building this architecture diagram as I go, so I haven't sat down and thought through the entire infrastructure, designed it end to end, and mapped it out. I will come back in this diagram and clean it up and make it more presentable. So you'll just see me just adding on blocks to this, and hopefully it's making sense. So the end-to-end system, I have a lot of the back end. So I'm starting with the back end first. Hopefully I'll get to the front end Alexa skill here in the next week or so. I'm hoping to actually start creating a skill. That's what I'm actually very excited about starting on. So hopefully we can get to that soon. But what do I have so far? So I have this system here which will get notifications. It will manage subscription to a notification service called PubSub. And this allows me to, when a new YouTube video is posted, I get a notification and then I can start to process it. So that comes in through API Gateway, which is a resource I deployed. I am using the service application model, which sits on top of CloudFormation, to deploy this entire infrastructure, which allows anyone to just click a button and deploy this entire infrastructure. So that signal comes in through API Gateway. I have a bunch of Lambda functions that are not represented here because I'd have Lambda functions all over the place. But the Lambda function will then kick off a state machine. And that state machine, which I use state machines to do orchestration, that state machine will go through, it'll first download the YouTube video, save that YouTube video in S3. It'll then call AWS Media Convert, which will take that YouTube video and convert it over to a file type that AWS services can use. And then it'll call Amazon Transcribe, which will read the whole video. It will pull out all the text. And then I call Amazon Comprehend, which helps me pull out key phrases and entities. The key phrases are especially important. And then I persist all of that inside a Amazon OpenSearch. And so I've created these indexes, which allows me to persist these entire transcripts. And that's what I'm going to end up searching. So last time I created a state machine to manage the subscription process. I didn't get done with it when I was done Monday, but I did figure out what I was doing wrong, and I fixed it. I'll go over that in a minute. And then the next piece of this is we need another state machine to go and get the entire archive collection of videos. So this is all set up to get all new videos. I need a way to go back and get all the archive videos, which we have hundreds and hundreds of videos. And this is going to be a little bit tricky because I'm going to use a state machine to do this because I want to throttle this. I want to do kind of one at a time. And the reason is a lot of these services have limits on throughput and how many concurrent, media converts I can do. Like I can't just convert 300 videos all at the same time. I will get throttled by AWS. And to be clear, there's probably some of these limits I could increase to say, allow me to do 300 at a given time. But there's really no reason to do this. This is a one-time job. I'll run, every time I add a new channel, which is going to be very rare, I'll run this state machine, which will go and pull down the entire channel. So if it takes a week to process, that's totally fine by me. And if it's processing while I'm building out the front end of the Alexa skill, all better, right? I have no need for all this data to be available as soon as possible. So I need to work on that, but I haven't found an API yet to go get index the entire YouTube channel. I haven't really looked for one, but I need to figure that out. I need to say, here's my YouTube channel ID. Go get me the entire collection of videos and the URLs to those videos, and then I can feed it into my standard state machine one by one. This standard state machine, which will pull it down and convert it and all that. And then once I have that, then I can start fine tuning my searching. I've already started doing this, so it's all in OpenSearch, but I need to. I'm not an OpenSearch or an Elasticsearch query expert, so I have to brush off my skills there on how do I actually want to go and query this data. A lot of that depends on how my interface is in my Alexa interaction model to say, how am I going to allow users to create these searches? If it's something like, show me about Alexa presentation language, that's easy because that ends up being a key phrase that Amazon Comprehend was able to pull out of the transcript. So I'm able to match on the key phrase. I don't have to match on the entire transcript. But if it just depends on how we want to actually set up the interaction model to allow users to be really conversational with this skill to say more complex things. So who knows? We'll design that. We'll get to that. But it may be show me from at least 2 weeks ago when this happened, right? I want to be able to query off a bunch of different parameters, and I'm probably going to be pulling down more than just the Alexa office hours videos. So I want to be able to search office hours, but also maybe tech talks and maybe some of the other lectures that we have on there. So that voice model is going to get pretty interesting. We'll start with a really simple one and keep building from there. And so this is what I'm excited about. This is actually what I'm paid to do, is like work on Amazon Alexa. So I can't wait to get to that point. But I need this whole entire infrastructure first. So again, this is all in GitHub. I have a repo. You can find me, Ryan J. Lowe. And this is Unofficial Office Hours. It's one of my pinned repos. So you should be able to find it pretty easily. I do try to commit to this when I'm done almost every day. I won't commit broken code, but I'm trying to commit to it. And so, yeah, so join me on this wild ride. I'm writing it in Python mostly. I do have some JavaScript because my YouTube library that I found was JavaScript, and I really liked it, so I'm using that. I'm kind of newer to Python, so I make a lot of Python mistakes, so don't make fun of me for that. But yeah, let's just kind of jump into it. Oh, the very last thing I should say is I want to give credit, like every single time I stream, to this blog post, which I found, which kind of helped inspire this whole entire use case. So this is a blog post from 2018 where they're doing very similar use case, but they're pulling down podcasts and they're going through audio files and indexing and making podcasts searchable. So mine's a little bit different. I'm doing videos, I'm doing YouTube videos, but I use this repo heavily. There's a GitHub behind it where I am borrowing tons of code. Like I just came in here and copy and pasted like all of the, they're using Elasticsearch at the time, but now I'm using OpenSearch. But I just came in and copied just tons of resources out of here. And then this is, let me close a bunch of this. This is my local machine where I have my repository pulled down. And again, I'm using CloudFormation and the service application model to define all my resources and deploy them up to AWS. So I'm doing infrastructure as a code, which again allows anyone to pull this down and start running with it. Okay, so that's a ton of talking. So where did I leave off? Hey, how's it going? Electricity? Hey, thanks for joining. So where I left off last time was I was working on, let me go back to my architecture diagram here. I was working on this state machine here, which would keep my pub sub going. Electrency. Cool. All right. Thanks for the phonetical pronunciation. Thanks for joining. So I basically this state machine is what I was working on. So when I'm using I have it here, Google's, in order to be notified of a new YouTube video that I can go and download, because that's my whole use case. I'm downloading YouTube videos and indexing them and making them searchable. I need to subscribe to push notifications. And so the way we do this is through a service called PubSubHubbub, which is a Google service to be notified of new videos. And you can create a subscription here. So here I'm saying my topic, my YouTube topic is this channel here. And then my callback, this is my API gateway endpoint. So I'm saying create a subscription to this where every time a new video gets posted, you ping my callback URL. This works great. When I get the incoming message from this, I'm able to process it. But what I found out was that this subscription, it doesn't live forever. It lives for about 5 days. So what I had to do was I create a state machine to keep refreshing my subscription. So now what happens when I request a subscription, I get pinged. So every time I subscribe, I get a ping that says, please acknowledge that this subscription is legitimate. So I acknowledge that. And actually my code to do that, I can just show that is right here. So this is my handler. It gets called by API gateway. So basically it comes in, this is the same API. So basically what I'm doing is if I get a notification from PubSubHubbub to say, do you accept this new subscription? What you have to do is you have to reply back saying, yes. It gives you a challenge. You reply with the challenge. And then PubSubHubbub says, great, we know that this is a valid subscription. And then from here on out, you get pinged with the Atom feed every time that a new YouTube video gets posted. Included with that original, like, do you accept this subscription? They give you how long this how long this subscription is going to last. So they tell you like this subscription lasts 5 days. They tell you 5 days in seconds. They don't tell you 5 days. And so here what I'm doing is I'm saying, great, this subscription, I'm acknowledging it. I say, yes, I accept this subscription. Here's my challenge response. And then what I'm doing is I'm saying, go create a new state machine, go execute a new state machine that waits for 5 days. And then when it's done, it calls a Lambda function to go renew the subscription. And then it calls a renew subscription, and then the pub sub hubbub will call back to this endpoint to say, do you accept this new subscription? And then I start it over again. And so if I go into my infrastructure in AWS, I have a state machine here that is doing exactly that. So it's running. This was kicked off when I renewed the subscription. It is in a wait state. It is waiting for, you can see here, this is 5 days and seconds or thereabouts. And then when this is done, it's going to call a Lambda function. After it's done waiting, it's going to call a Lambda function to refresh my subscription. Again, that goes out to pub sub hubbub. Pub sub hubbub then calls my API to say, do you accept this? And then that API will kick off a new state machine. So I'll always have a state machine instance running where it's just constantly just waiting for that subscription to end so it can refresh it. So that's what I worked on Monday, and it is working. And then I was able to get a new notification, came in last night, to say a new YouTube video is posted. So yesterday we did office hours. The office hours ended. It seems there's some sort of delay between when you do a live stream on YouTube and that video becomes available in your channel. It seems to be about 12 or 14 hours. I'm not sure they're doing some sort of back-end processing, obviously. So when that triggered, then I was able to get this. So I was just able to download this YouTube video from yesterday where we did a live stream and process it. And what I've been doing is I've been playing around inside my OpenSearch database with different ways of querying this data. So as an example here, if I just do a search, like a blank search, it'll show me all my office hours. I have a few office hours episodes that I've already downloaded. And then here, what I'm doing is I'm playing around with different ways of searching. So it's Amazon OpenSearch, but it's also, it matches the format of Amazon, or not Amazon, the open source Elasticsearch. So this is the same sort of syntax. It's just Amazon's OpenSearch version of that. So what I'm doing is I'm playing around with these different ways of querying. What I was wanting to do is verify that we do in fact have data from, so yesterday would have been the 15th. So if I query this, here I'm getting data back. And so here you can see, this is really cool. So it went and indexed the entire hour-long video and broke it up into different paragraphs. Each one of those paragraphs are then annotated with different tags, so that we're able to then kind of zoom to that point in time. So here I did, one of the questions that came up yesterday was in-skill purchasing. And so here I did a search for explicitly the office hours from yesterday to make sure I'm only searching that one. I just want to make sure the data's there. And here I'm getting back results that talk about in-skill purchasing. So if I'm using this query string, which is not the greatest. I'm just basically playing around with different types of syntax here. I'm not sure exactly what's going to be the best way to query this. Again, I'm not quite a Elasticsearch expert. I'm probably going to play with this quite a bit. And I actually don't want that. I want just maybe match. Is that what I'm looking for? I don't know. I need to figure this out. But query string is one way to search, which is, oops. Let me do this then. Let me go back to what was working. So I will work on this kind of in my spare time to figure out what is and I have something malformed. Query malformed, no start object after query name. Let me just go back to what was working. I'll read up on There we go. That's what I was looking for. I'll read up on Elasticsearch and kind of figure out what are going to be my search criteria in terms. But this should hopefully be pulling back. It's probably just getting the term skill. It's a really aggressive. This is a really aggressive syntax. Let's see if this is working. Nope. Anyway, I'll keep playing around with this. But the main thing is that it is getting data into the OpenSearch database. And that's the thing I was just wanting to get done. So I'll evolve this over time. I need to read a ton of Elasticsearch documentation to figure out what's the best way to match this. The other thing is I can match off of here. This is another way I can do it. So I was playing around with this earlier. So this allows me to match off of the key phrases. So I'm using Amazon Comprehend to pull out key phrases. So this is being returned by Amazon Comprehend after I transcribe the whole video. Here it's coming through and finding key phrases inside of that transcript. And so here I was just doing a test to see if I could match upon those key phrases. So what I was looking for is yesterday I was talking about this tutorial workshop called Cake Time. Yes, and I was able to pull it from yesterday. So here I'm going off the key phrase. If we come over here, there it is. Cake Time is a key phrase of this block of text. And so by searching out the key phrases, I was able to find this, which is kind of cool. So this is probably how I'm going to be. I'm just playing around with this a bunch to see what's going to happen, what's coming out of this. But again, I won't live stream learning how to query with Elasticsearch, just to show you that it is there. Okay, so we have a lot of this working. There is one change that I need to make to, let me go back to my diagram, to this diagram. So originally, so one interesting thing, the Atom feed that I get notifying me from PubSub Hubbub of new YouTube videos, there's an interesting thing that happens. When we go live on YouTube, that's one of the platforms we go live on when we're doing these office hours. We go live on YouTube, but we schedule that. So we go in and we schedule and say, hey, we're going to go live Tuesday morning at 9 a.m. Pacific time. When we schedule that, a notification actually comes through PubSub Hubbub to say, hey, we have a new thing on this Atom feed. Which is interesting for other purposes to say like, hey, tune in later because these guys are going to be talking about this. I can't use that event though. What I was doing was I was just kind of saying like, okay, great. Let me parse out the start time of that and then let me wait an hour and let me process the video when that live time is done. Well, the way this works, I kind of went through this like a couple weeks ago. The feed at that point in time isn't quite ready. They have to do some background processing, and then it's like usually like 12 hours later that we want to actually do something with this. So I need to update this to ignore that first event. That first event does trigger the whole process. I want to ignore it because it's of no use to me. And so what I'm going to do is I'm going to come in. Is actually the best place to do it would probably be on this API call. So this is the first step in my state machine that kicks off. Let me minimize this now. So if I go over to here, this very first step here is it gets the information about the YouTube video, and then it waits. And the idea was I wanted this to wait until the live stream was done. So look at if this was that, hey, we scheduled a live stream event, parse out the date and time, and then add an hour to it and wait until that point in time is done. I don't want to do that anymore. In fact, I don't even want to wait anymore. I just want to ignore that first event and then process the second event that I get, which is the one that comes 12 hours later. So we're just going to process that and use that event. So I need to modify my state machine and get it more up to date. So this is the code I had to do that. Again, this is the very first step in the state machine. So the incoming event to this Lambda function only has the YouTube URL. And the response, so I can look at this here, is the YouTube URL. And the response is how long to wait and then a bunch of metadata about that YouTube URL. And so here I'm like figuring out how many seconds to wait and all that. And actually what I want to do is only if it's okay do I want to proceed. If it's not okay, then just disregard this whole run. So what I'm going to do is instead of seconds wait, I'm going to get rid of this. I'm just going to say YouTube status. And I'm just going to pass in this value here, which is part of the, I'm calling an API to go get me all the details about, like the metadata about this event. So I'm just going to say, I want to get rid of all this and only if it's okay. So let me just copy this or comment this out for right now. So now I have YouTube status, which should be okay or something else. If it's something else, I just want to ignore it. And then I'm going to come into my state machine and we're going to modify the state machine. I'm growing a lot of resources now. So this is that Lambda call. And then this is the wait phrase that I want to get rid of. So actually what I want to do is instead of a wait, what I want to do is do a choice. So type choice. And let me copy this down here. So choices. So I'm going to have two different paths. So a choice allows the state machine to branch and go in two different directions. So the default path is going to be YouTube download. So actually, so let me look up my syntax for state machine choice. Again, I'm wanting to make a branch to go one way or the other. Okay, so this is what I'm looking for. Okay, so a choice allows branching logic inside a state machine. So if the Lambda returns anything besides status okay, I want to just end is really what I want to do. Okay, so choice rules. Numeric equals, string equals. What I want is like not equals. So how do I use this not? Okay, so I think I want to do, that's interesting syntax. I've never used this before. So I only need one. So what I'm doing is I'm saying the default path is going to be just go on to the next step, YouTube download. If not, variable, what I call it, status, YouTube status. If not, YouTube status, string equals, okay, then we're just going to go straight to, I think we have an end path on this already ready to go. Yeah, we're just going to go straight to end. And I just want to make sure I called it end. Yep, we're just going to go straight to end. Okay, so now it's going to call this, state machine will kick off. It's going to grab the information, and the state machine is going to, or this Lambda is going to get called. It's going to return all this information, including YouTube status. The next thing is it'll say, let's not call this YouTube wait, let's call this YouTube decision, or let's call YouTube OK filter. So it'll get the information, or it'll turn to OK, a YouTube OK filter. It'll do a choice. Default will just be go on to the next path. And if it's not anything but OK, then go to end. So this should work. And let me get rid of, I have that in version control. If I need to go back to it, I can find it. Okay. This simplifies this Lambda function. I love state machines because it allows me to write really simple Lambda functions, right? This Lambda function has one purpose. It calls a YouTube API using this YouTube client and returns the metadata and then just continues on. Then that's it. And then the state machine takes over and decides what to do. So I could put that if-else logic in here, and then I could create a mammoth Lambda function that does everything. But I don't want to. I don't want to have one Lambda function does everything, because later I do a bunch of long-running processes that take a long time to run. Specifically like transcribe. So I don't want to wait for the transcription to finish in Lambda because I'm paying for that idle time. So as I do is I kick off a transcribe job, and then I go back to steps functions and I say just wait. And then that waits, and then the next step is it just checks periodically. And since I'm in here mucking with the state machine, I should also go ahead and update that, because I have a lot of these waiting for 30 seconds, which is really, really quick. I want to actually change this to, let's wait every 2 minutes. Because what's happening is my state machine is looping way too fast. And none of this is real time anymore, because I'm already I have to wait till the YouTube video is processed, which is hours later. So if this whole job takes an hour to run, if I'm waiting too long, then that's totally fine. Okay, so let me try to deploy this code. That is the wrong screen here. Again, I'm using SAM to do this. So what I'm doing is I'm running a SAM command. I don't have Docker running. Okay, let me run Docker. I forgot I did a restart on my computer. So Docker is starting up there. So what does SAM actually do while it is building? So what's happening is it's going in, the first thing it's doing is it's going into all the different Lambda functions. So as an example, this YouTube get info, there's a folder called YouTube get info. Inside that folder is my JavaScript file for my Lambda function, but also includes dependencies. And so what SAM is doing, I've defined that location inside this YAML function. In fact, let me pull that up. So here is the definition of that function, the infrastructure of that function, to say, here's where the code lives. I need it to run for 20 seconds. It uses this runtime. Here are the environment variables to pass into it, and here's the policies it needs. It needs to be able to write to DynamoDB. And then what SAM is doing is it's saying, okay, go to this location, Lambda, YouTube, get info, and compile that function. It uses Docker to compile it so it matches the infrastructure of AWS. Creates a zip file, and then uploads that zip file to S3. And then it comes back and says, now do you want to deploy, do you want to deploy these changes to your infrastructure already in AWS? So here it's saying, here's everything that's been modified. Do you want to update this? And yes, I do want to modify all of this. And so now it's going to go to my AWS account and make these changes. And hopefully I didn't have a typo in my state machine Java or JSON, which unfortunately happens. I'm trying to see if my internet is getting any better. I use Starlink, and it's been great up until like the last week or so, and now it is not doing so great. It seems to be doing pretty good today, so let's hope it keeps it up. I'm sure. Look at my my stream information. Oh, it does not seem to be doing well. Darn, that's too bad. It seems to be very unstable. Sorry. Okay, so this got updated. I am recording these locally, and then I'm also going to post to YouTube the recorded version, not what's on Twitch, until I get my internet under control, which who knows when that will be. Okay, so this is the state machine how it was. If I go back and come into a new definition, it should have yes, it looks quite different. That is not how I would have rendered it, but fine. That's totally fine. Interesting. So this is the new state machine. Man, that's hideous. I wish that would render differently, but that's okay. So here it has a filter to say if it's not ready, then just ignore it. Don't even say it failed. Just ignore it, and everything's happy. Okay, so we have that working. That's great. Now what I need to do, and I'm kind of kicking myself I didn't actually dive into this a little bit deeper, but I need to find I need to work on this state machine here, which allows me to go get all the archive data and start processing it one by one through my normal state machine. So I need an API, which will allow me to go get, based upon a channel ID from YouTube, all the videos in that channel. All I really need is the URLs to those videos. And so I just need to figure this out. So I am using, what I was starting to look at was I'm using this library here in Node to call and download YouTube videos. I was wanting to know if this had an API, what I was looking for. Let me go to the actual GitHub repo of it. And I was also looking at the response JSON that I get. So I call, in order to get this metadata, like title, name, publish date, I'm calling get info on the actual YouTube URL, and it gives me a ton of data. And I was looking through the response of that to see if it had like the channel information in it. I kind of hope it doesn't. It does have like related videos. I think that's what this thing, like this is like a ridiculously long payload. So it does have related videos, which is pulling from the YouTube channel, but not it doesn't have all of the videos. So I don't want to use this while it is giving me a great index, but it's probably also going to pull from other channels as well. So I was looking to see, look at this. That's funny. I was doing a search for this to find, like, get all the videos on a channel. And they might have one. YouTube might have one in order to do it. Oh, that is not a helpful URL. But I'm worried about the key there explicitly. Okay, so let's search for content. What I want is search by, and sorry, I didn't figure this out ahead of time. We're just going to just work through this. Channels list by channel, retrieve channel data. I do have my channel ID up here. Here it is. Let me authorize this. Cool. Well, that does give, okay, so I'm able to hit the channel. That's exciting. I was hoping for like a free API. So let me, before I go back to this, which I'm fine using an authenticated one, I'd rather just use one that's just completely free. So this is the Node library I'm using. It seems to be fantastic. I'm using it to download the stream of an individual URL, and it's a really, really handy library. But what I was looking for was to be able to pull down by channel. Resolve YouTube playlists. I just have to play around with this. Okay, attempts to resolve given playlist ID or channel URL. Resolves the uploaded playlist. Playlist URL. We don't have a playlist. We're not doing a playlist. But what I can do is I can, so let me copy this code and let me create a new Lambda function. So here I'm going to say get channel. So here I'm going to say the packages I need. I'll include that one, but I'll also include this one. What version are we at here? 2.2.3. 2.2.3. And then here's what I'll do. I'm just going to hard code some stuff. So here, so what I'm doing is I'm creating a new Lambda function. I'm going to use SAM to deploy this Lambda function with my dependencies up into AWS, and then I'll go into the AWS function and start playing around with it and having fun. So let me just get something that is compiling. So here, let's do this and let's give it my channel ID. I'm just going to hard code it just so I can get something up into AWS. And okay, and then I need to come in and actually add this to my template. So I can tell Sam you need to deploy it. So where is lambda get info? It's this guy. So I'm just going to copy that definition and come up here, create a new lambda function, YouTube get channel, YouTube get channel. I don't need to write to DynamoDB, but let me just leave that in there for right now. I think it won't hurt anything to have that in there. Okay. In fact, I'll just get rid of it now. Okay. So now I've added this to my, I don't know how long the API is going to take, so let's give it some time. I've added this to my infrastructure. So I've created an empty Lambda function just to test out this new library. I've added that infrastructure as a code here. So now I can deploy it up to AWS using SAM. Found the new function. Just compiling it. It should now give me a change set to say, do you want to deploy this? It should have a Lambda function in a role. It's discovered that need to be updated. It skipped all the other functions because I'm using I'm using the cached version of the SAM command, so it's not recompiling every single function. By default, it'll recompile every single function, which is great for like CI/CD builds. You want to always make sure that like you start from scratch on everything. I got lazy of waiting for it to recompile everything. So change set should find two things. It should find the Lambda function and the role. So let's see if it finds it. And again, my Lambda function is empty shell. I'm just trying to get up to AWS so I can start playing with it. Let's see if that, big things I want to see if that library even gives me anything. So yeah, found the two things, great. Now I'm going to deploy it. This should be pretty quick. So I'll come over to CloudFormation and get ready. Creating progress. Has to create the role before it can create the Lambda function. Let's check on my stream stats. They are still absolutely garbage. It's raining. I don't know if that's going to make a big difference. My average bit rate is less than 3,000. That's fantastic. Okay, come over here. So now I should have a Lambda function. Let me click on that from CloudFormation. And bingo, there it is. Everything that I've just wrote. Okay, so let's just see what happens if I execute this. Test. I need to give it a test input. Okay. So I'm going to go over to CloudWatch. I think the logs will be better there. It seems like there's a large payload. So when I ran this, it did return stuff. These look great. This looks like a ton of stuff. Maybe I can pull open. Hold on just a second. So this is where I'm going. So I'm wanting to download, like, get a list of all these different videos, right? So here's a bunch of office hours, but there's a bunch of other stuff in here as well. And I want to download and index and transcribe all of it. So let's see what this API gave me. Oh, come on. Did I screw up my permissions? Please tell me this has access to even right to CloudWatch. Yeah, it does. So maybe it just didn't. Maybe I clicked on view logs in CloudWatch too early. Cool. Okay. So let's see what this response is. Okay, so this looks cool. Uploads for Alexa developers. So let's look through this. Items, office hours 15th, 8th. What challenge? This looks fantastic. What is talk socket? That's another video. There's more office hours. This looks perfect. And this is the URL I can pass off to my state machine to go get all the rest of it. This looks phenomenal. Look how far back this goes in one API request. And that's it. That is awesome. How long is that? I pulled back 100. Sweet. This is an awesome little library. That is cool. That makes me happy because I don't want to have to like mess around with authenticating to YouTube. Because then I have to worry about shared secrets and refreshing tokens and blah, 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 blah. And I just don't want to have to do that. What's interesting is it didn't give me a continuation token. Oh, maybe I didn't. Maybe I need to be more explicit. So let's, what was that? Playlist at items. Let me see how long this is. Yep. And then playlist dot, what was it, continuation? This only seemed to have brought back the first 100, but then I didn't get a continuation token. So I think if I provide something like this, it might, oh, I need to do dot links. We'll see what happens here. So here I'm gonna just log out the length. I forgot to deploy it. Okay. Now let me test it. Okay, so it did bring back, now I have a continuation token, right? If I come down to the bottom here. Oh, right. Pardon me. Okay, so let me look at the CloudWatch logs. Hundred. So I did that, and then I just did it. Oh, I didn't actually log the playlist anymore. That's totally fine. Okay, so can I do this? Let C equal. What's the best way to do this? While true. Oh my gosh, I'm switching between JavaScript and Python too much, and my brain is going crazy. If playlist.continuation equals null, then we break. Let total equal 0. And then how do I pass in the continuation? Oh, just, okay, so maybe I want to do something a little different. Do let playlist equals this, while playlist dot continuation does not equal null. Oh my gosh. If I could type, that'd be awesome. Okay, what am I doing? And then playlist, so now this is what I want to do. Await playlist.continuation. Okay, so we call it once. We get pages 1, get the total. If there is a continuation token, then we continue and do this loop. I don't need a let there. Playlist equals that. Keep adding the total. Okay, let's see what happens here. So hopefully this is going to tell me how many total. 602. We have 602 videos on our YouTube channel. Wow, that's more than I thought. That's kind of cool. Okay, so basically what I want to do is this is going to go into a state machine, and I'm just going to add. So this is going to go into a state machine, and what do I want to do? I want to loop over each one of these 602 videos and download them, but I want to download them one at a time, and I download them by calling another state machine. And so the way I want to do this is what I could do is just create a really long running Lambda function that just called the state machine and then waited for that one to finish, then called the next state machine. That is a terrible way to do this because I don't want to pay for Lambda to be running. I want to pay for Lambda to run, execute once, and get all of this. I'm just going to clean this up. One Lambda function is going to go and say, here's all 602 items. Hand that over to a state machine and go running with that. So what I want to do is I want to create a state machine that can take the response array of 102 items, or however many there are, and loop over them one by one. This is not something I've done before, so I may need to do a little bit of research here. So let me minimize that. So what I want to do is I want to take the response from, state machine loop over Lambda response array. There's got to be a way to do this. So you take, so again, I want my state machine to have like an input which kicks off where you just pass it in channel ID. It calls this Lambda function that we're authoring right now. This Lambda function will go and find all the amount of arrays, and then I want to return that back to the state machine, have the state machine loop over each of those. That's what I'd love to do. I'm not entirely sure if that is possible. Use a state machine. So here's I just did a quick Google search. Iterate a loop a specific number of times. That's not quite what I'm looking for. The other way is I could start by that's one way to do it. Okay, maybe I can do that. Okay, I have an idea. So let's not, we need to start capturing the, we need to start capturing the YouTube URLs. So, and of course I didn't actually grab that. Oh, but I can just go back to my previous. Okay, so what am I looking for? I am looking for, I need these URLs. No, I need this URL, the short URL. That's what I need. Okay, so what am I doing? I'm doing urls.append. Oh no, am I mixing up? I just want to do concat. I'm switching back and forth between Python and Node too much. Okay, so I want to concat current URLs with, let's do playlist.items.map. We want to take in the item, and we want to return item dot, was it short URL? So I'm just pulling off the short URL off of that. So let me do this. Console.log URLs. That did not work at all. Oops. Oops. Yeah, why can't I console log that? Let's make sure I am Not missing any meetings today. Fantastic. Yeah, see, that worked. Oh, but you know what? I should probably assign this. That'll work. This should work. Sometimes I'm not a software engineer. Yeah, I know. Okay, so now I have this array of a bunch of YouTube videos. So this is awesome. So what I'm going to do is I'm going to return back to the state machine. What I'm going to do is I'm going to say URLs. I'm going to say index is 0. And we'll just say total. We'll do length. I like that better. Length is total. Okay, so now let me actually go back to my local and start actually coding this for real. Okay, so this is the first step in my state machine. The next step is I need a lambda function that will take these one by one and basically initiate the other state machine. Yes, that's what I want. So let's create another lambda function. And this one I'm actually going to do in Python. So I want to get back to Python. So this one is going to have the ability to execute a state machine. So I actually have a lot of that already here. So I'm defining my new infrastructure, trigger state machine. It's actually going to be a new state machine. No, it's not a new state machine. This is going to go into a new state machine, but it's going to trigger this state machine. But I need more. So here I'm just starting execution. I need to actually figure out how to get the status of it as well. But so this will be YouTube video start state machine. Call it state machine start. Come on. And then hopefully this will all make sense in just a second. So then I'm going to have another one that's going to be state machine status. This one is going to have permissions to get the status of a running state machine, which should be called get describe execution. Is that what I want? Yeah, that is actually what I want. Describe execution. On my other state machine. And this is all going to come together in just a second, I promise. So I need to create these two new Python functions. So let me YouTube callback your. Let's start with this one and copy it and paste it twice. So the first one is, oops, this one is actually status. Forgot to rename that. status. The other one is YouTube start. Okay. Now let's go into, close that one, close that one. Let's go into this one, the start one. Let me pull it over here. So this one now is going to, let me get rid of all this stuff. So it is going to, okay, so this is the first step in the state machine. It's going to go and get, it's going to take a channel ID. So let me actually change this to event sub channel ID. It's going to take a channel ID from the state machine. Actually, you know what? I'm not going to do it that way. I'm going to do it like const equals. Am I doing this anyway? I want to make sure I'm consistent with the naming convention, because that kind of stuff I worry about, but nothing else. I'm not doing it. That's fine. So let me do this, go back to my template. So now what I've done is I've introduced a new environmental variable called channel ID, which I think I have, what's the name of it? The name of it is YouTube channel ID. As I have this as an input to my whole template. So if I come back down here, what I'm doing is I'm altering the infrastructure of this Lambda function to say I'm passing in as an environment variable the YouTube channel ID. So now my function here has the channel ID as defined by the CloudFormation template, which is cool. Now I don't have to hard code anything inside of here. Okay, but this is going to return back these values, and I want my state machine to always return back these values, but I'm going to modify these values. Okay, so here we're going to do this. So this is the state machine. This is the Lambda function. It's going to start the state machine. It's going to download the entire thing. So here we're going to say we're getting, okay, I need to get the state machine URL or the ARN. State machine ARN. This will be this guy. Now I have the state machine ARN. And I shouldn't have been so aggressive at deleting all that code. Let me go back to here and copy and paste the code to start a state machine. Okay, so here, this is how we start that state machine. We're just passing in the URL and then returning. So, but what's the URL? The URL is actually going to be one by one through that giant array. So what we want to do is we want to say index equals, how do I want to do this? Do I want to, yes, I'll do this way. URL equals event. Now this state machine is going to, or this Lambda function is going to get past these three variables in the event. So what I want to do is I want to say event sub URLs sub and then event sub index. So this is going to return back the same full list of URLs. The index we're going to increment. +1, and the total will also just be the total, or the length. And what I should do is put this into a variable so I can log. I don't need. Okay. So I am kicking off the state machine with the URL at the current index of my giant array, and then this one is done. This Lambda function is done. The next Lambda function, okay, the next Lambda function is going to check on the status of the state machine, or actually the execution. So I need to pass back the execution ID of this response. So start execution should return back. Interesting. Oh yeah, the ARN execution ARN. That's interesting. They're not using IDs; they're using full ARNs for the execution. All right. So response dot execution ARN. So now in my other, this is now the function where it's going to check on the status. So what I want to do is I want it to have the same response signature. But now this time what I'm going to do is I'm going to call client.describe execution on my Botto, or my step functions Botto3 client. Okay, which just takes in the execution ARN, which is kind of what I was expecting. And this actually comes from the event. So here I can say and so here I want the status. What I want is the status. Okay. Now, so now what do I have? I have a Lambda function that's going to start the state machine. It's going to call the API, get all the URLs for all the videos that we need to process. Then what it's going to do is the next step in the step function is going to be to one by one go through that array and trigger a step function. So it's going to trigger the other step function to execute. We'll trigger that. We'll then wait in a loop. We'll say, is this done? If it's done, then go on and trigger the next step. So I want the other step function, the one that's processing, downloading, and transcribing all these videos to be one by one through the whole system. So we're going to have to do 2 separate loops here to get through this, which should be kind of fun to do. Okay, so let's define the state machine now. I'm going to do it up here. And actually, now I'll just do it by hand. I do have a smaller state machine that I can copy. I really need to reorganize all this stuff. So I need the state machine and I need the role. I need to reorganize. What I was getting at is I need to reorganize all these resources to kind of make them a little more organized. I know where they all are in this big giant YAML file, but it makes no sense. Okay, so this is going to be my process archive, video archive, state machine. And so we need a role down here. Cool. So it needs to be able to execute these 3 functions. So we'll give it those permissions. That's what this role is saying. This role that this state machine is going to run under has permissions to invoke these three functions. And then those three functions will get placed in here. So I might as well do that now. So this is how I build out my state machines. I do it in, it's JSON syntax inside of a giant string that has string replacement variables inside of a giant YAML file. There's got to be a better way to do this, but this is how I know to make it work. And so that's what I do. Great reasoning, I know. Okay, so there is my state machine. Now I need to actually change this. So we're going to start at the first one, which is get YouTube channel, or get all videos. So this is going to be a type task. The resource is this guy, which I'm going to do a string replace on. So it'll get replaced with the actual ARN. And then next is going to be, what do I want to call this? Start new state machine execution. Okay, so it'll call this function, and then the next step is going to be another task. Oh, yeah, I need to actually put this in as a variable so it will get string replace. The next task is actually going to be start the next YouTube. So this executes. It will go and get the array. It's going to call this lambda function. It's going to get an array of all the URLs. I'm going to set the index as 0, total array to that, and this will end. The very next step, as I'm saying, once this lambda function is done, call this lambda function over here on the right, which is going to take the first index off the array and call the state machine, another state machine, to go and process it. So what we want to do now is we want to wait. Wait for execution. Because this state machine takes like an hour to run sometimes. So what I want to do is I want to wait a good length of time to make sure the state machine has time to finish before I execute the next state machine. So then the next step is going to be a wait. This is type wait. I believe it looks like this. Seconds. Let's do, how long does this thing, let me actually look at the data and see how long this last one took to run. So this took about, what was that, 25 minutes? Again, I'm not in a hurry to make this actually run super quick. Because I suck at math, let's do it that way. So here it's going to wait that long. That should be enough time for it to finish. And then next is going to be check state machine execution status. Which is also a type task. But now the ARN is for this ARN. And then next is going to be check if complete. Okay, so next we'll do this step here, which I need to make sure it's actually complete. So I may bring this down. Let me actually bring this down to like 900. So, because I'm going to create a loop, and I don't want it to like, if it waited 30 minutes, but it actually was going to take 35 minutes, then it would say after 30 minutes, not finished. So it would go on to the next iteration of the loop and wait another 30 minutes. So this time I'm going to have it only wait 15 minutes. Again, It really doesn't matter if I'm waiting too long, because this is something that only needs to run once. It's going to take a really long time to process this anyway. So, okay. Here, this is going to be a choice block. So let me go back down and copy my choice block syntax here. Here it is. Okay, so choice. The default is going to be go back to start state machine execute. But if it's anything but, what is the actual response to this API? Actually, I may want to not do it this way. How do I do the other choices? Is that the only choice? I think this is how I want to actually do it. Let's be more explicit. Oops. Are you kidding? Let's be explicit about the different responses. So what it's going to do is it's going to look at this execution status. So if execution status is, I already have the default. Default's going to go back to, so if it's running, then go back to wait. If the status is succeeded, then it starts the next one, which is great. If it failed or timed out or aborted, I think we need to just end it. So maybe I do actually want to do the not. Or do I want to continue on? So if it failed, maybe I do want to just continue on even if it failed, and then go back and pick up the ones that failed. Maybe that's what I want to do. Okay, so running, go back to wait, succeeded, just do the next one. If it failed, or timed out or aborted, maybe I do just want to like go back and just keep going anyway. Okay, so that's what I want to do. I just want to do this. So here the default is to go back and start the next one in the index, or the next YouTube video. If it's running though, then go back to wait. And then I actually need to do another if block, don't I? Because I need to check on the index values. So, and that actually needs to be done. I should probably do this. That needs to be done up here. Check index. So default. So actually, kickoff, we get all these. I want to go straight into check index. The default value is going to be to go to the next value. But if the variable of index is, I don't want to do a string equals. Numeric equals. But it's actually numeric equals path. Numeric equals path. That's what I want. Okay, so if index is equal to $length, then go to end, and we need an end state. And then this actually needs to be there, and we need an end. I always like having an explicit end. I don't know why. Okay, so let's review this. State machine kicks off, has no input because I'm passing in the channel via the environment variables. It comes back and returns an array of all the YouTube videos. Hopefully there's not a max length on how many parameters you can pass in. We'll find out. It passes in the array of index, which will be 0 the first time through, and the total length. So next thing is it comes down here and it says, if the index is equal to total length, 0 is equal to, let's say, 10, then we're done, end. Otherwise, default value is to go to this. So it comes in here, and it grabs the current index, URL here, and processes it, or kicks off a state machine to go process it. Now we're going to wait 30 minutes or 15 minutes, and we're going to check on the status. It calls this one to get the status of that executing ARN. Ooh. I only want to index it or increment it there. That would have been a bad typo. Then now it goes to check complete. If it's still running, go back to wait for execution. Otherwise, go to check index. So it goes back around here. The index is incremented, so now it's 1 versus the length 10. If that's equal, then go to end. Otherwise, go to the next step. So I think this is good. I think I can build all this and compile it. It is not good. Okay, so what is it mad about? Probably failed to parse template while parsing block mapping. Probably have some indenting that is bad. And I do. That's bad. There it goes. Easy enough. So now it's building those 3 Lambda functions. It is, that's what it's currently doing. And then it's going to do a change set where it's going to deploy probably at least 8 things. The 3 Lambda functions, the 3 Lambda function roles, the state machine, and the state machine role. So my guess is it's going to come back with change set, say, do you want to deploy these 8 changes? It's uploading the zip files of those compiled Lambda functions. Now it's creating the change set. My guess is 8, but there's always a chance that other resources are identified as needing updated as well because of this. Man, my internet's been really choppy. It's kind of driving me nuts. But I live in the middle of nowhere, so I don't really have too much of a choice on what kind of internet to get. Yeah, it's basically saying my Twitch inspector is basically saying this is complete garbage the entire time. So sorry. And there we go. There's only 7. Oh, right, because I didn't modify. Oh, yeah, didn't modify the Lambda role. That's close. My guess was close. Okay, deploy this. So this step is where CloudFormation is going to try and deploy my infrastructure. This usually fails if I screwed up this JSON syntax to define the state machine, which happens a lot because it's just a giant string. So this does happen frequently for me. Let's hope it doesn't. Because I'd love to kick this off. I have to end the stream, but I'd love to kick off this state machine just to see if it actually worked or not. And if it actually like starts the first YouTube video, or if there's way too many videos. Like I'm passing an array of like 600 YouTube video URLs. I have no idea if state machine can handle that big of like payload going back and forth. I think it can. I've never tried that big. I could read the documentation and find out, but that seems like a lot of work. Come on. It created the role. That's cool. This is where it would fail. And dang it. Oh, okay. What's wrong? Unexpected. Okay, so one way I can easily just do this and figure out what exactly is wrong if I just go into the AWS console. This is always the easiest way. So I'm going to say, let's create a new state machine. I want to write my own code. Where is the typo? Expect a JSON string instead of. Is it really? Boy, you're an idiot. Always some mundane detail. So now it's rolling back all the changes it just deployed because I had a failed creation of that resource. Hopefully this doesn't take too long. Sorry guys. But let's also make sure that was like the only typo. This is gonna be mad because it's not really an ARN. I get that. That's mad because that's not an ARN, and that's not an ARN. So those three errors make complete sense to me, but it looks like the rest of it is valid, just missing those ARNs. This rollback is actually a really, really cool feature of CloudFormation. The fact that like I had a working architecture deployed. I tried to deploy bad architecture. It failed. And so it's going to roll back those changes, leave me back to the state I was in before that was working. That is really, really cool and really, really powerful feature of CloudFormation. And then I can version control this entire code, this entire infrastructure as a code. So if I want to, I can go back to how this code was operating 3 days ago. Even though I've rewritten a bunch of functions and redone a bunch of stuff, I can go back to that point in time. That is really, really cool. And that's something you don't get. Like if you're mucking around with, like I went into the AWS console and was mucking around with the Lambda functions directly. I can't go back in time in those. There's no way to version control that. It's just whatever it is saved at that moment in time. So if I like made a mistake and needed to go back, I can't. And so here I'm doing everything locally. I can deploy it and I can go in and modify it and play and do stuff like what I just did today. But mostly I can just redeploy it up and it will get my infrastructure back to how I want it. So this is taking a little bit longer. I think I do need to end the stream. I will get this to a point. I have to go check in on my other part of my day job and make sure that I don't have any emails or stuff. I will get this working today. I will kick this off, and I just want to see if it's actually going to start processing. But I think I do have to end the stream now so I can move on with my day. I'm really disappointed this didn't get done. But I think it was just that one typo. Now it's actually going through and deleting everything. But I am going to end the stream. So again, I'm on 3 days a week, Monday, Wednesday, Friday, doing this, building this skill. I think I'm going to get to a point really soon. I'm hoping next week where I can start on my actual skill. I may actually be able to start stubbing out my skill, actually start the code and bringing and defining some of that infrastructure. I might be able to actually start doing that on Friday if this actually worked and start processing these files. And I do have a bunch of cleanup I got to do as well, so I might end up just doing that. I'm not sure. I'll figure that out before now and Friday. But thank thanks for watching. I hope this is educational. Maybe someone else can be inspired by this. Maybe someone learned something from this, or maybe someone can take this and build something really, really cool off of it. So anyway, I really appreciate anyone following me along, and have a great day. Thanks.